Okay guys, today we're going to talk about how to solve what's called a difference of squared. Okay, now to be a difference of squares, you can only have two terms, and remember terms are separated by subtraction, addition, and equal signs. And then what has to happen is that your first term has to be a perfect square, your second term has to be a perfect square, and you have to be separated by a subtraction sign. So if we look at number 1, x squared is definitely a perfect square because we can rewrite x squared as x times x. Now, since that's the exact same thing being multiplied by it, x squared is a perfect square. That means y squared is also a perfect square, and it's separated by a subtraction sign. So this is a difference of squares. Now the difference of squares factors into what we call conjugates. So here's how we factor this. We are going to take this difference of squares and factor it into two sets of conjugates. Now conjugates look almost exactly the same, but the only thing that's different is the subtraction sign. So here's what we need to do. First, we need to take the square root of my first term. So the square root of x squared is just going to give me x. And that is going to be the first term in each one of my conjugates. Then I need to take the square root of my second term, this x squared, or excuse me, y squared, and the square root of y squared is going to give me y. That's going to be my second term in each one of these conjugates. Now all we have to do is make one a plus sign and one a minus sign. So if we factor x squared minus y squared, it turns into x plus y times x minus y. Now if you want to check that, you can always FOIL. If I take my first, I'm going to get x squared. Outside, I get minus xy. Inside, I get plus xy. And last, I get minus y squared. Now these two terms cancel out, and that leaves me with x squared minus y squared. So a difference of squares, these two dudes right here, factor into what we call conjugates, where the first term and the second term are the exact same things, and the only thing that's different is the is the sign. So let's look at it again on number 2. The first thing we need to check is to see if my first term is a perfect square, and my second term is a perfect square, and to be separated by a subtraction sign. So if we look at number 2, the first term is 49x squared. Now we know that x squared is a perfect square because we just figured that out up here. So now I need to see if the coefficient attached to it is also a perfect square. So 49, if you're not sure, you can always check in your calculator, but you should know the first 15 perfect square numbers since we went through and learned those on the first day. So 49 is a perfect square, and x squared is a perfect square, so that means this whole term, 49x squared, is a perfect square. 36 is also a perfect square, and it's separated by a subtraction sign. So I'm going to separate these into conjugates, and to find my first term here, I need to take the square root of my first guy. Now the square root of 49 is 7, and the square root of x squared is x. So the square root of 49x squared is 7x, and that goes in both of them. And then the square root of 36 is 6. Then one needs to be plus, and one needs to be minus. Let's try it again on number 3. So 16a squared. 16 is a perfect square, and a squared is also a perfect square. And then 9b squared would also be a perfect square, so we need to separate these into conjugates. And the square root of 16 is 4, and the square root of a squared is a, so that's going to be my first term. And then the square root of 9 is 3, and the square root of b squared is b, so 3b is going to be my second term. One's plus, and one's minus. So all we're doing is taking a difference of squares and factoring it into what we call conjugates. Let's look at number 4. I have 225b squared minus a squared. Now 225 might be a little bit hard for you to figure it out, but remember it's still on that list of first 15 perfect squares. 225 is a perfect square number because 15 is the square root of it. So 225b squared is a perfect square, and a squared is a perfect square separated by a subtraction sign. So again, we've got our conjugates. The square root of 225 is 15, and the square root of b squared is b. So 225b squared splits into 15b, and then a squared turns into a, and one's plus and one's minus. Now on number 5, if you guys look right away, we have 72, and 72 is not a perfect squared number. So this is when we start to bring in what we learned in the last section. So today not only are we focusing on difference of squares, we're focusing on factoring completely. And when you factor, you need to go through a thought process. Now the first thing you need to look for whenever you're faced with a quadratic to factor is you need to look for the greatest common factor, which is what we looked for last time. The second thing we need to look for is the difference of squares. Okay? Now on number 5, 72p squared and minus 50. The first thing I want to look for is the greatest common factor. Is there greatest common factor between 72 and between 50? They're both even, so yes, a 2 can go into both of those. Now when I factor out a 2, let's see what's left. 72 divided by 2 is 36p squared, and then 50 divided by 2 is 25. Now I can look at what I have left on the inside. Just because I've taken out a GCF doesn't mean I'm done factoring. We still have a power of 2 up here, so I want to see if I can keep going on the inside of my parentheses. So 36p squared, that is a perfect square. 25 is also a perfect square, and it's separated by a subtraction sign. So 36p squared minus 25 can still be factored as a difference of squares. So the first thing you want to do is bring down your 2, because we factored that out, and then I want to break this difference of squares into my conjugates. So the square root of 36p squared is 6p, and the square root of 25 is 5. Then 1's plus and 1's minus. So it's really important that you keep the 2 here that you factored out. It doesn't go away. It's still part of your factoring. And if you were to refoil, you could multiply these two binomials together, and you would get back up to 36p squared minus 25. Then you could redistribute this 2, and you'd get back up to 72p squared minus 50. So again, first thing you want to look for is the greatest common factor. Then we look to see if we can difference of squares. So on number 6, 6 minus 54a squared, the first thing we want to look for is a greatest common factor. Well, 6 can go into both 6 and 54, so I'm going to take out a 6. And let's see what I have left. 6 divided by 6 is 1. Negative 54a squared divided by 6 is negative 9a squared. Now let's see if I can keep going. So 1 is a perfect square, and 9a squared is also a perfect square. So I'm going to bring down this 6. That doesn't go away. And this can factor into its conjugate. So the square root of 1 is 1. And the square root of 9a squared is 3a. So I'm going to have 6 times the quantity of 1 plus 3a and 1 minus 3a. Now let's look at number 7. Again, the first thing I want to look for is the greatest common factor. Not just a factor, I want the greatest common factor. So the biggest number between 8 and 200 is 8. That can go into both of them. Now let's see what I have left. 8y squared divided by 8 leaves me with y squared. And 200 divided by 8 leaves me with 25. Now I want to see if this guy is a difference of squares. Y squared is a perfect square, and 25 is a perfect square. So I can bring down my 8 and set up my 2 new binomials. Now the square root of y squared gives me y, and the square root of 25 gives me 5. So I have y plus 5 and y minus 5. On number 8, 16x squared minus 49. First thing we should look for is the greatest common factor. So 16 and 49 are not both even, so 2 can't go into it. 4 can go into 16, but not into 49. 8 can go in, but not into 49. So it doesn't look like we have a greatest common factor here. But that's okay. Now let's see if it's a difference of squares. So 16x squared is a perfect square. 16 is a perfect square, x squared is a perfect square. 49 is also a perfect square. So let's make our 2 binomials and see what we get. So the square root of 16x squared is 4x, and the square root of 49 is 7. Then 1's positive and 1's negative. So you might take out a greatest common factor, and you might not. What's important is that you always look for it first. So what I'd like you to do is pause the video and try number 9 on your own. So when you factor 4x squared minus y squared, you should get the quantity of 2x plus y and the quantity of 2x minus y. Now what's important to realize that it doesn't matter which binomial has the plus and which has the minus. If you got your answer to be 2x minus y and 2x plus y, that's the same thing, and you would get full credit for that. That is the correct answer. On number 10, I have 4x cubed minus 100. So the first thing we want to look for is a greatest common factor. So 4 and 100. 4 can definitely go into both of those. Now if you'll notice, my first term has an x to the third power, and my second term has an x to the first power. So I can take out an x with the lowest exponent, which is to the first. Now let's see what I have left. 4x cubed divided by 4x leaves me with x squared, and 100x divided by 4x leaves me with negative 25. Now, inside of my parentheses, I have an x squared minus 25. I can still factor that by the difference of squares. So I'm going to bring down my 4x and then set up my two binomials here. The square root of x squared is x and x, and the square root of 25 is 5 and 5. One's positive, one's negative. Let's try it again on number 11. 2y to the fourth and 32y squared. So 2 can go into both 2 and 32. And then each term has a y, so I can take out a y, and the smallest exponent is 2, so I can take out y squared. So let's see what I have left. 2y to the fourth divided by 2y squared. 2's cancel out, and I'm left with y squared. 32 divided by 2 is 16, and then y squareds cancel out. So I'm left with 2y squared times the quantity of y squared minus 16. Now, y squared is a perfect square, and 16 is a perfect square, so this is a difference of squares, so I can keep going. So I'll bring down my 2y squared, and then y squared, if I take the square root of that, I get y. And if I take the square root of 16, I get 4. So I get y plus 4 and y minus 4. Now what I'd like you to do is pause the video and try number 12 on your own. Alright, hopefully you factored out an 8, m to the first, and that leaves me with m squared minus 16. Then you can bring down that 8m, and you're left with m plus 4 and m minus 4. Okay, so now let's move on to how to solve these equations. So on number 13 it says solve each equation by factoring. Check the solutions. So I have 81x squared equals 49. Well, before I can solve this, the first thing that I need to do is I need to set it equal to 0. So I'm going to subtract 49 from each side, and I'll get 81x squared minus 49 equals 0. Then I'm going to look at what I have on the left side here, and I'm going to look for a greatest common factor between the two terms. So 81x squared and 49, there are no common factors between 81 and 49, so there's no GCF. The next thing I'm going to look for is to see if it is a difference of squares. So here, my first term is a perfect square, my second term is a perfect square, and it's separated by a subtraction sign. So I can factor this difference of squares into two conjugates. So the square root of 81x squared is 9x, and the square root of 49 is 7. Then one's positive, one's negative. But don't forget, we can't solve it unless it's set equal to something, so bring down your equals 0. Now we can use the zero product property to get two answers. Remember, the zero product property states that if you have two terms multiplied together and they're equal to 0, you can take each one of those terms and set them equal to 0. So my first term here, this 9x plus 7, I can set that equal to 0. And my second term here, 9x minus 7, I can set that equal to 0. Now I have two linear equations that I can easily solve. So if I were to solve my first guy here, 9x plus 7, I would start by subtracting 7 from each side, then dividing each side by 9, and x would equal negative 7 over 9. My second guy here, I would add 7 to each side, divide each side by 9, and x would equal 7 over 9. So my two answers are negative 7/9 and positive 7/9. Let's try it again on number 14. The first thing I want to do is I want to subtract 1 and set it equal to 0. So 36n squared minus 1 equals 0. Next, I want to look for a greatest common factor. So, since I have a coefficient of 1 here, there can't be anything that's taken out, so there's no GCF. Now let's see if it's a difference of squares. 36n squared is a perfect square. 1 is a perfect square. So this is going to factor into my 2 conjugates. So the square root of 36n squared is 6n, and the square root of 1 is 1. 1's positive, 1's negative, and don't forget your equal 0. Now I need to take each one of my terms and set it equal to 0. I can take 6n plus 1 equals 0, and I can take 6n minus 1 equals 0. Now all I have to do is solve. So on 6n plus 1 equals 0, I can subtract 1 from each side and divide each side by 6. And on 6n minus 1 equals 0, I can add 1 to each side and divide each side by 6. So my 2 results are negative 1/6 and positive 1/6. Let's try it again on number 15. On number 15, I hope you'll notice that this one's already equal to 0, so I don't have to worry about subtracting anything over. The first thing we need to look for is a greatest common factor. So I have 25d squared minus 100. Right away, I'll hope you notice that 25 can go into both of these. So let's factor out a 25 and see what I have left. If I take 25d squared and divide it by 25, I'm just left with d squared. And if I take negative 100 and divide it by 25, I'm going to be left with negative 4. Don't forget your equal 0. Now, let's see if I can keep factoring. D squared minus 4. D squared is a perfect square, and 4 is a perfect square. So bring down your 25, and this d squared minus 4 is going to break up into 2 conjugates. So the square root of d squared is d, and the square root of 4 is 2. 1's plus, 1's minus. Don't forget your equal 0. Now if you'll notice, on this guy I have 3 terms that are multiplied together to equal 0. So I'm going to take all 3 of them and set them equal to 0. So I can take my 25 and set it equal to 0. I can take my d plus 2 and set it equal to 0. And I can take my d minus 2 and set it equal to 0. Now let's solve. If I look at my first equation, 25 equals 0, right away I hope you notice that there are no variables in this equation. And they're just telling me that the number 25 is equal to the number 0. And we all know that that's definitely not true. So this doesn't give me an answer. D plus 2 equals 0. We can subtract 2 from each side, and d is going to equal negative 2. D minus 2 equal to 0. We can add 2 to each side, and d is going to equal positive 2. So my answers here are negative 2 and positive 2. On number 16, we have a fraction, and fractions are not something that we want to deal with. So the first thing that we need to do is we need to multiply the entire equation by the denominator of that fraction to eliminate it. So here, the denominator is 4. Let's multiply the entire guy by 4. So 4 times 1/4 x squared. 4 times 1/4 cancels out and gives me a 1x squared equals 4 times 25 gives me 100. Now we can set it equal to 0. I'll subtract 100 from each side, so x squared minus 100 gives me 0. Then I want to look for a greatest common factor. But here's a hint. If you eliminate a fraction by multiplying the denominator, you are eliminating all possibilities for a greatest common factor, so there shouldn't be any. Now, let's look to see if this can factor into a difference of squares. My first term is a perfect square, and so is my second term. So that means it's going to factor into conjugates. Square root of x squared is x, and the square root of 100 is 10. 1's plus, 1's minus. Don't forget your equal 0. Finally, take your 2 terms and set them equal to 0. X plus 10 equals 0, and x minus 10 equals 0. If I subtract 10 from each side, I get x equals negative 10, and if I add 10 to each side, I get x equals positive 10. So my 2 answers are negative 10 and positive 10. Let's go over to number 18 over here. Again, we have a denominator of 100, so I want to start by multiplying the entire guy by 100 to get rid of that fraction. Now, 100 times 49 over 100, those denominators cancel out and just leave me with 49. Then 100 times x squared gives me 100x squared. Then 100 times 0 just gives me 0. Now let's see if this is if there's a greatest common factor. Since we multiplied by the denominator to get rid of it, there should be no greatest common factor. Now let's see if it's a difference of squares. Is my first term a perfect square? It is. Is 100x squared a perfect square? It is. So that means this is going to factor into conjugates. So the square root of 49 gives me 7, and the square root of 100x squared gives me 10x. 1's plus, 1's minus, and don't forget your equals 0. Next, we set each of our terms equal to 0. So I get 7 plus 10x equals 0, and 7 minus 10x equals 0. Then all we have to do is solve. Here I can subtract 7 from each side, then divide by 10, and I'm left with negative 7 over 10. Here I can subtract 7 from each side, and I can divide by negative 10, and I'm left with positive 7 over 10. So my two answers are negative 7/10 and positive 7/10. On number 19, the first thing we need to do is we need to set this equal to 0. So I'm going to subtract 25x. So 9x cubed minus 25x equals 0. Then we need to look for a greatest common factor. So 9x cubed minus 25x. So 9 and 25 do not have anything in common, but each term has an x, so I can factor out an x. Let's see what I have left. 9x cubed divided by x gives me 9x squared, and 25x divided by x just gives me 25. Now I can look to see if this is a difference of squares. So 9x squared is a perfect square, and 25 is a perfect square. So this can factor into conjugates. Bring down your x and make your two binomials. The square root of 9x squared is going to give me 3x, and the square root of 25 gives me 5. One's positive, one's negative, and bring down your equals 0. Now we have to set each one of our terms equal to 0. So my first term here is x. My second term is 3x plus 5, and my third term is 3x minus 5. Now my first equation, x equals 0, doesn't need to be solved. X is already by itself on one side of the equal sign. This means that one of my answers has to be 0. The second equation, I need to subtract 5 and divide by 3, and I'm left with negative 5/3. My third equation, I add 5 and divide by 3, and I get positive 5/3. So my three answers are 0, negative 5 over 3, and positive 5 over 3. Now this is different than what we did on number 15, because on number 15, when we took out the greatest common factor, we got an equation that didn't help us because there was no variable, and we only got two answers. But on number 19, when we took out the greatest common factor, it was a variable, so it did give us an answer. This is something that you want to be very careful with. If your greatest common factor does not have a variable, you're not going to get an answer from it. But if your greatest common factor does have a variable, it will give you an equation. Another trick that you can notice is that if the degree of your equation is 3, you're going to have 3 answers. But if the degree of your equation is 2, you're only going to have 2 answers. So let's go to number 21. First thing I want you to do on 21 is subtract over and set it equal to 0. So you should get 2m cubed minus 32m equals 0. Then we're going to take out the greatest common factor. So 2 and 32 I can take out a 2. M cubed and m, I'm going to take out an m. Notice I have a degree of 3 here, so I should end up with 3 answers. Let's see what I have left. If I take 2m cubed and divide it by 2m, I'm left with m squared. 32m divided by 2m gives me 16. Don't forget your equal 0. Now I still have a difference of squares here, so I can bring down my 2m, split this up into two binomials, and the square root of m squared is m, and the square root of 16 is 4. So I have m plus 4, m minus 4, and equals 0. Now I take each one of my terms and I set them equal to 0. So 2m equals 0, m plus 4 equals 0, and m minus 4 equals 0. Here, if 2m equals 0, I divide by 2 and m equals 0. Over here, I subtract 4 and m equals negative 4. And here I can add 4 and m equals positive 4. So my three results are 0, negative 4, and positive 4.